So a big welcome to today's class. It's a fascinating class today in that we look at the relationship between mathematics and critical thinking. And then in the second class, we go on and look as Christians at mathematics and our faith in God. Maths is a fascinating topic in that we often dismiss maths as simply using numbers in calculation or doing lots and lots of classes from prep and year one all the way through primary and secondary school, while we scratch our heads and ask why and what's the meaning of maths and why do they give us so much maths every year. And we're going to try and answer that question today, and then we're going to look at the answer from a Christian perspective. But before we start, let's start with a Bible reading from Psalm 94. Take notice, senseless ones, unwise amongst the people, foolish ones. When will you become wise? Does not he who fashioned the ear not hear? Does not he who formed the eye not see? Does he who disciplines nations not punish? Does he who teaches mankind lack knowledge? And we could add, does not he who creates mathematics and the mathematical world know what maths is all about? The Lord knows all human plans. He knows that human plans are often futile. Blessed is the one that you discipline and teach, O Lord, the one you teach from your laws, which could also include mathematical laws. They could be part of our formation. Unless the Lord has given me help, I would soon have dwelt in the silence of death. When I said my foot is slipping, your unfailing love, Lord, supported me. When anxiety was great within me, your consolation brought me joy. And I could add, when I struggled in maths classes, somehow you helped me through. So today we're setting out to look at the relationship between mathematics and critical thinking, thinking well, thinking clearly. We want to recognize ways of using maths in critical thinking. And then we want to, in the second session, more go on and look at order and beauty in maths and recognize relationships between order and beauty in maths. And then we want to recognize ways in which critical thinking in mathematics can increase interest amongst the students and show relevance by using real life examples. We want to think of ways we could reduce maths anxiety, encourage students to recognize that maths can be valuable, relevant, fun, interesting, and that they can be creative, and difference can be valued in maths. We encourage students to recognize that it's okay to get answers wrong in the learning journey, and we could encourage students that maths doesn't have to be rushed. And just as an example of this, can I get each one of you at the beginning to quickly write down in a couple of seconds how many dots are there? So you got 1, 1,002, 1,003, 1,000. Write down how many dots. Belinda, how many dots?
10.
10. Now, the really interesting question, Belinda, is how did you quickly work out 10?
I looked at the top 3, times that by 2, and then added 4.
3 times 2 plus 4. Excellent. And then Alex, how did you work? What number did you get?
Over 10 as well.
10 as well. Excellent. And then the question that's really interesting is, how did you work it out?
I saw the 6 in the middle. That's what the dice looks like. So I knew that was 6, and then it was easy to tell the other 4 remaining.
Right, 6 plus 4. And then Martha, how many?
10.
And how did you work it out?
I got that because I kind of saw, like by supervising, I saw 3 3s and 9, and then added 1.
Yeah. And then Gabriella, how did you work it out?
I went 3, 6 in the middle, then plus another 3, then plus another 1.
So it's 6 plus 3 plus 1. And Karen, how did you work it out?
I read just left to right on 3, 3, and then down the bottom an offset 3, and then just add the 1.
Yeah. So 3, 3, 6, 1. Now notice here, the point is, every one of you has probably worked it out differently. And often when we teach maths, we teach that there is one way to do things. And one of the points we're going to suggest today is that God gives us creative abilities, and they're often different. And one of the dangers is that we often say, this is the way to do it. And that's very much an adult child downward approach to instruction, isn't it? Whereas another way of doing maths would be to recognize that it's a creative learning process in which you should be free to be more creative. Have I told you in a previous class about in Tasmania, in Launceston, in northern Tasmania, a student there attended his primary school class piano lesson, and he learnt the piano, and then when he went home from his first lesson, he started to write his own songs. And then he went back to the piano teacher next week and showed that he'd written his own songs, and he was given the cane, because you're meant to be practicing the piano, not writing your own songs. His name was Peter Sculthorpe. He went on to become one of Australia's great original musician composers, despite a teacher saying, you need to follow these guidelines and rules and not be creative. And the trouble is, maths can be a bit like that, that rather than encouraging the creative ability that God has given us, maths can often be, this is a set of propositions that you've got to follow. Martha, what's wrong with teaching, which is set instructions you must follow? If you're teaching cooking, and there are people in my family who say that you must follow these instructions. If it says 2 eggs and a quarter pound of butter, you're not allowed to be creative in cooking. And the same with music, you know, you've got to strum exactly as it's written. Martha, what's wrong with that as a teaching approach?
Well, from a musician's point of view, writing or playing things exactly the way they're written, you miss a lot of the heart, and the way that it's presented is different, and the feeling and things. So in teaching, I guess, yeah, it's just missing the creativity, and you could be, I guess, dismissing something that potentially could be really, really great in a child.
Yeah, and certainly there's a place for accuracy and repetition. But what we're saying here is that there's also a place for freedom, creativity, enjoyment. Alex, what do you think about these two approaches to education? One, you must follow exactly what I do. And secondly, what do you think are ways of working this through?
Yeah, I think that when you're too strict and you have a set of propositions that they have to follow, then I think that it will limit a student's creativity in other subjects as well. And so when they are given the opportunity to use their creativity, I think that they might be limited to what they've been taught.
Yeah.
And yeah.
And certainly in the modern world, we would argue that when you get a job, you need freedom, flexibility, decision making, that you can't just be following a set of rules. Sometimes when you answer the telephone, people all feel they've got to have, you must always say these exact words when you answer the telephone. But then I think like Henry Ford's manufacturing system, if you're just doing one thing repetitively, then that can get boring, and it doesn't value what it means to be a human person. It's dehumanizing. And so one of the things that we notice with mathematics is it's possible to be dehumanizing in the way mathematics is taught. So we're going to think a little bit about what maths teaching is about, and we're going to look at some examples. One of the first maths textbooks, I don't know if you've got one of these on your bookshelf. This textbook has possibly sold more copies of this book apart from the Bible, which has had more copies. And this is a page from 75 to 125 AD. It was found in 1897. And this is Euclid's Elements. And so if you go to Euclid's Elements, then you can download this. And I think I've put it up on Moodle. And this was written in 300 BC. And this was a collection of all the teaching that you need for maths and for geometry. And so this is Euclid's Elements. So let me go here and put it up here. Yeah. And so let me drag that down. And so you can look through this, but just a quick glance at this shows, firstly, in teaching maths, you can begin by saying a point, and then a line doesn't have any breadth that joins 2 points, and then a straight line, and so on. So these are the basic ideas in maths, and then geometry, and then you've got the theory of circles. And so in algebra, you can have 2 lines, and then there's the angle between the line, and then the angles can add up in various ways, and so you can work out the material. What I find is amazing is that this was written and circulated and taught in maths 300 BC, and students would often do primary school maths in ancient Athens and Greece for their 6 years or so, and then they go on to high school maths through to about age 16, 17, 18. Then they'd have 2 years of military service, and then they would come back, and as part of their education beyond that, as they went into tertiary studies, they would do further maths. So maths was seen as an essential part of your educational journey back 300 BC. And not only that, maths was seen as part of your spiritual formation or your character formation. That is, the exact ideas in maths reflect the exact ideas and perfection that there is in the realm beyond this material realm that Plato describes in the forms. And as your life aligns with the perfection that's out there in the eternal realm, then your life goes well. So this is Euclid's Elements. So we'll memorize all this for next week when we'll have a test on Euclid's Elements. Hopefully I'm seeing smiles out there. And then we've got the different propositions for numbers. And it's interesting, a lot of these ideas about numbers and angles and geometry are still much the same as what we have in mathematics in our education and teaching all these years later. And so we still have arithmetic where we add and subtract and multiply. Back then they had abacus and ways of doing calculator. We still do that. We still have the natural numbers, 1, 2, 3, 4, 5. Notice that 0 is not a natural number. Negative numbers are not natural numbers. So if you're $3 in debt then you don't really have any money. You're actually $3 in debt, and $0 is not actually a number. And then in the natural numbers, you've got the whole numbers and then the fractions. And then algebra is where length times breadth will give us area. But if we don't know what length and breadth is, we can still write length times breadth, L times B, or A times B. So algebra is where you use letters for unknown quantities and equations. And then geometry is where you draw shapes like triangles and rectangles. And then you use these all the time when you build a house or build a road. And then you've got set theory. So if you're part of a group, then there's a set within the group. If you've got a class and there's 25 in the class, then that's a set. So set theory. And then trigonometry, if you're going to use right angles, and then you're going to use sine and cosine. So all of this was used by the Greeks and the Romans and people in ancient times in Egypt and Babylon. And then you've got probability, whereby you work out the chance. And then the really interesting one is calculus, where you have change over time and it could increase over time. So this is partly the ancient world, but it's also partly the numbers that are all around us. I guess one of the points we're going to make today is that there seems to be a sense of order in the universe, and maths describes this order in some ways. And so it describes the movement of the planets around the sun. It describes gravity going down towards the center of the earth. It describes so much that's happening all around us. Now, the big question we're going to ask today is maths an invention of people, or is it really there? And one of the examples I read about is, if Shakespeare writes Romeo and Juliet, and if I print that on a piece of paper, or write it on a piece of paper, is Romeo and Juliet what Shakespeare wrote, what Shakespeare thought and wrote in the mind of Shakespeare, or is it the letters on paper? So if I hooked up 10 printers and got them to print 10 copies of Romeo and Juliet, and I got Shakespeare to talk to me and say, tell me what your idea is, and Shakespeare said Romeo, Juliet, the Capulets, and then I typed it, type, and then we printed off 10 copies on the 10 different printers. Where is the real idea of Romeo and Juliet? In the mind of Shakespeare, or on the 10 paper copies that we print off? Gabriella, where is the real Romeo and Juliet? In the mind of Shakespeare, or in the 10 paper copies?
Well, I think it's real in Shakespeare's mind because he created it, but then it becomes tangible, for want of a better word, I don't know, when it's written down. But like, it's no less real in his mind. I really don't know.
That's well said. So it's real in the mind of Shakespeare in its origination, in its origin. So if you took away the mind of Shakespeare, would there be a Romeo and Juliet? No. But if you took away one of those 10 copies, would there still be a Romeo and Juliet in the mind of Shakespeare? Yes. And even if you took away 9, there'd still be a Romeo and Juliet in the mind of Shakespeare. So it becomes, what was the word you used? Communicatable, or?
I said tangible.
Tangible, yeah. So we can actually then see it because it's seeable now, because it's been expressed that way. Yeah, that's good. Belinda, your thoughts. Where is the real Romeo and Juliet, in the mind of Shakespeare or in the paper?
I agree. I think it's in the it's in the mind of Shakespeare. He's created it. He's thought of it. It's image there, but he's shared it to others. So it's been shared on the printed papers. So now it's out for the world to be in his mind also.
Yeah, so it actually enters our minds. So that's interesting. So we can actually share in the joy of that story. Alex, where is it?
I think it's also in the mind of Shakespeare.
Yeah.
But I really agree with what Belinda was just saying, and how he's made it available for us.
Yep. And Martha, your thoughts?
I could say what everyone else says, and I agree. Yes, it's in the mind of Shakespeare, but obviously, if I want to get all spiritual, God created the mind of Shakespeare. So actually, we could say that originated from God. That's just because I want to get a gold star for spirituality.
Yeah, so there's a potential in God's creation of the mind, and that is even more miraculous in that he gives us that canvas on which Shakespeare then uses, which is then printed out on paper. That's excellent. And Abby, your thoughts?
I'm just going to agree with everyone. So it was in the mind of Shakespeare.
Yep. And Karen?
Sorry, I gotta find the unmute button. I see. I think it's difficult because one thing that my English teacher always told me was once the idea has been written down, it's no longer it's no longer
Yes.
the author's. It's interpretable by the reader. So I suppose in a way, yes, it originated in Shakespeare's mind, but the Romeo and Juliet, which we are using to define the idea of it, the entire idea of it has been written down, and therefore I believe it's in both. It's both in Shakespeare's mind. So if Shakespeare were to die, we still have it physically, but if Shakespeare's alive and the physical copy gets burned, it's still there. Now, if both of those get destroyed, then it's gone. But unless somebody else had remembered it, as I think it was, I can't remember who was saying, maybe Gabriella was saying it. Somebody said that it's also then in our minds as well. So I suppose information in that way is sort of just contagious.
Now, it's interesting. The printed copy is like the shell of a sea creation or the skeleton. And if you lose the printed copy, it's like losing the skeleton shell. The real living thing is the mind of Shakespeare and the mind of the reader. And this is what Plato was trying to say, is that the real living things are the unseen realm in the mind, whereas we live in a modernist world, an Aristotle-like world that focuses on the printed material and it overlooks the mental. And the same is true of maths. If you take 2 apples and add 2 more apples, you've got 4 apples. But the 4 apples is not just humans describing 2 plus 2. It's actually a concept that is there before the 2 apples come along. And so that's what Plato was arguing. Pythagoras was certainly arguing that. Idealists are arguing that there is a real ideal world out there before mathematics comes along. And that's what we're looking at a little bit today, is that ironically, the real is the unseen. And that's where logic is engaging with the real, whereas the seen, like the printed pages of Romeo and Juliet, is but a shadow on the wall in Plato's cave of the real, which is in the mind of Shakespeare, made by God, and also in the mind of the reader. And that's where a lot of very interesting things are going on, is in people's minds. So that's the second point we're wanting to make in today's class, is that maths should be interesting, creative. You can do it in different ways. And maths also should recognize that there's ideas out there that are real and to be discovered. And it's an exciting process when you discover the invisible mathematical rules that govern the universe. This is what got Einstein excited. This is what got Isaac Newton excited. This is what got Leonardo da Vinci excited. They were discovering the unseen realm out there, like a treasure trove of unseen concepts. And maths is part of that excitement. Now, maths is very applicable in life. So if you buy a car, you use numbers to calculate fuel consumption, kilometers per litre, depreciation, interest on loans, all of that, maths. So maths is used in the world all around you. We've got to use it to identify deception. When someone gives us 10 cents and tells us that it's $10, you've got to be able to spot that. Sometimes children want the coins because they're more familiar with them than a $50 note, which they're not familiar with. And so you've got to have an understanding of maths to realize what's going on. One of the big ones at the moment that puzzles me is inflation. So I've got a little bit of money in the bank, and my money in the bank, I think, is earning 3%. And I'm told that the inflation rate last year, with a low inflation rate, was 3.5%, which meant that my money actually was getting smaller by 0.5%. So numbers tell us what's happening in the unseen world. Another application of the unseen world and maths is in terms of health. And so I've given a bit of thought to this. I'd like to travel overseas soon. And people tell me you can't because you'll get struck down by these illnesses that are out there if you travel overseas. So I'm trying to work it out. Interestingly, I had a life insurance policy, and I looked up how what my chances of living are. And I looked at, I've probably got, say, 40 years to live. And my life insurance was worth, say, $100,000, and divide that by 40 years, and so on, 2,500. But they're wanting about $3,000 a year for me to pay for my life insurance. So when I did my calculation, I thought, I'm paying more than it's worth. So I rang them up and chatted to them, and they said, we don't usually have people ring up who can understand what life insurance means. They were quite surprised by that. I said, well, can you explain to me why I'm paying so much and getting so little? And so we had a bit of a chat. In the end, I decided I wouldn't go ahead with that one. So maths can help us in making decisions. The Spanish flu pandemic in 1918, 2.7% of people who caught it, or 50 million people, died. And so you knew your chances if you caught it was, fortunately, you had 97% or 97.5%, 0.3% chance of surviving, but you did have a 2.7% chance of dying. COVID fatality rate, sometimes at the beginning of the COVID illness, it was up to almost 20%, 1 in 5 could die. And then they worked out what treatments they could use. They got it down to about 5 or 6%, 5.8%. And then they even got it down below 1% to 0.7%. The most common COVID fatality rate that I've seen is about 2% if you're not vaccinated. However, that'll be lower than that now because we have other treatments like we do for pneumonia. So it's probably might be down below 2%. Seasonal flu has a fatality rate of about 0.1%, which is about 1 in 1,000. That's still pretty high, isn't it? So people die every year from the flu, but it's 10 times higher rate from COVID. The problem, however, with COVID is that because there's no resistance, there's resistance to flu out there. And so you get less people getting ill from flu. But if there's no resistance from COVID, we could have had more people very ill with COVID than hospitals could cope with. So that's partly what the whole kerfuffle is about. Now I think they're just saying our hospitals can cope, we've got immunity out there, and if 10 a week die then in each state, then that's part of life. I don't know if that's a way to go, but yeah. So you can see that maths can help us think through health decisions. I went with my wife into the doctor recently, and she had to get treatment, and she took some tablets, but they made her feel ill. And we asked the doctor, what's the chances if we stop taking the tablets? The doctor hopped on his computer, tick, 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 typed in a few numbers, and he said, at the moment, you've got an 87 to 88% chance of survival. If you stop taking the tablets, it'll drop down to 86 to 87%. And my wife looked at it and she said, I'll stop taking the tablets. Other friends would say, you can't do that. You got to take the tablets. But there's statistics out there, isn't it? I mean, if you hop in a car, you could work out what's the chances of a car crash. And if you hop in a car and you drink too much or whatever, eat the wrong things, you could work out they increase your chances. If you smoke too much, you can work out what the chances are. So there's a lot of statistics that could be helpful to us out there. So maths is useful, helps us understand. Like wisdom in the Bible, mathematics can give you wisdom and help you make decisions. Maths can help you think. They tell me that if you do some maths every day, then you'll think much better. For instance, if you have 2 shots and a booster shot, mortality rate can drop. And so you can work out. So maths can help you understand these things. Maths can help you understand how things work. So if you open up the bonnet of your car and see bits under there, I think it's very scary what's under the bonnet. But maths could help you to understand that certain things need to be followed. Maths can help you understand about health again. So the average risk of a person developing breast cancer, and this is in the United States, is about 1 in 10, 13%. So you've got a 1 in 8 chance a lady developing breast cancer. Now this means you could ignore it. You've got a 7 in 8% chance you won't catch the disease, but you've got a 1 in 8% chance, which is why they recommend mammograms, etc. Cigarette smoking. 480,000 people in the US of A die per year from cigarette smoking. I mean, more chance of dying from that than you have winning a lotto or something. 41,000 a year die from breathing in smoke smoked by other people. So there's 1,300 a day in the US dying from cigarette smoking. Exercise. I thought this is one that applies to me anyway. Is exercise lowers your chance of premature death by 30%. So that's pretty high, 1 in 3. Exercise reduces your risk of stroke and coronary heart disease by 35%. 50% less chance to get type 2 diabetes, 68% chance if you fall over, you won't fracture your hip. So maths can help you all over the place. It's a large part of everyday life. About 94% of all people who work in a job use maths somewhere in their job. 68% use fractions, decimals, and percentages. So knowledge of maths is very, very important. Maths also promotes a sense of cultural unity in that there's no race division, geographic division. Maths is the same, whichever country you're in. However, there can be division between those who can do maths and those who can't. Maths promotes wisdom, and maths can help you in all of these areas of life. So these are all ways of understanding what maths can do. Just want to give you an example here of doing maths, and now when you do maths, one of the first things you need to do is to think about the problem. So if you're asked to do a landscape construction or do a building or something like that, you've got to think it out. Like, let's say we do a circle and we're going to make it grass or something like that. We want to work out the area of the circle. Firstly, you might want to work out the circumference, the distance around the outside of the circle. Karen, any ideas how we work out the circumference, the perimeter around a circle?
It's been a very long time since I paid attention to that. I think it is, was it 2 pi r, 2 times pi times the radius?
Yep, sounds good. Alex, any thoughts? Do you know this one? Yep, so it's 2 pi
I would agree
r.
with Kieran, yeah.
Yeah, so the diameter, which is the distance across the circle, is 2 times the radius. And then by definition, pi, which is 3.17, is the number of times greater to go right round the circumference. So if you drew a circle, then the distance across the circle is 2 times the radius, and then pi is the distance around the edge. So that's called 2 pi r. So circumference by definition is 2 pi r. So it's the distance around the outside, and 2 times the radius is the distance across the middle. So that sort of makes sense. Now, in this video here, if you wanted to work out the area, you could take little slices of the circle all the way through and stack them next to one another, and you'd have a triangle, which would be about half a rectangle, and then the longest piece around the outside would be the circumference, 2 pi r. So if you add them all together, it would be radius times 2 pi r, which would be pi r, a half of 2 pi r squared, which would be pi r squared. So that's the way to work out the area. So there's the circumference, makes little triangles, and each triangle is half the circumference times the radius. So there, you can do calculations like that to work things out, and it's take a bit of time to work through it. In a maths class, you could work through it. But one of the things that we're wanting to say is that in maths, you want to be clear, you want to be cohesive, you want to be elaborate, appropriate, precise. But one of the other things that we're also saying is that you want to recognize that there is a beauty and an order in maths that can help you understand the beauty and order that's out in the world. So if you look all around you, there are mathematical examples all around us. And so there's maths all around us that we could understand the beauty of it. Leonardo da Vinci, he was so convinced that there was God's beauty that in his drawing and artwork, one of the things that he's seeking to try and do is to work with the beauty of ratios. Now, of course, Leonardo da Vinci was an engineer and he designs water systems. And then in his spare time, he paints things like the Mona Lisa and makes models of flying contraptions and all of those things. But it was his understanding of the beauty of the language of God, mathematics in the universe around us, that led him to this idea that there is a golden ratio, a perfect relationship between the length of one side and another side, which is the ultimate beauty that's in mathematics. And so all around us, there are these elements of beauty that in triangles, there's elements of beauty that you can use to understand the world that is around us. And so that's all part of the task of mathematics. Can you see that the task of mathematics really combines this emphasis that we have on clarity, elaboration, cohesiveness, appropriateness, being precise? So we want people to eventually be able to be exact, but at the same time, there's a free creative process in exploring the possibilities and the ways of working things out. And that's what we want to do in the maths process. We don't want to just say, this is the only way to do things. We want to say that there is a variety of ways of doing things. Maths often seems to be very man-made. We learn about maths and history and we think we're in control. This lesson today has argued that, like Shakespeare dreaming up his Romeo and Juliet, maths seems to be already there, and we're discovering something that's written in the universe when we discover 2 + 2 or circumference of circles or algebra. It's already there and we're just discovering what's there. So it's part of God's world. It's part of the unseen world. And it's part of the world that remains after our physical life in the eternal realm that's outside of our realm, is one way to see it. Certainly there are a couple of other ways to see maths. One way, as I said, is simply the only things that are real are the physical things you can see in the moment that are concrete, and then Plato was wrong and idealists are wrong. Some people think that way. Some atheists think that way. If I can't touch it in the present, it's not there. But maths seems to tell us about a world that's beyond this present world. And there seems to be a connection between the maths world, the unseen world, and the present world that we live in. And it's made partly in our minds, and that's part of the fascination. How do our minds work? How come our minds are so wonderfully created that they can work with the unseen? If you learn through education by what you can see, how come we can learn maths, which is unseen stuff about an unseen world? So Plato's theory was the unseen is real. There's ideal forms out there. And as we engage with these, we're engaging with the beauty of the unseen world that's out there. So can I get you to write down, what are some things that have stood out to you today in looking at maths? So we've done a bit of reading for the forum. There's maybe some other reading you've done. We've gone through the class. What stood out to you today from our class on maths? Because maths seems to be out there in the natural world. It's all around us, but it's like the canvas on which a painting is painted. It's before all things exist. Gabriella, what stood out to you?
I liked how you were saying that maths like shows the order and everything of the world. I don't know, that's just kind of cool. So
and do you think that can contribute to formation? That is, can students learn that because there's order in the world or in this unseen realm, it helps them if they bring some order in their life and disciplining? Any thoughts on that?
I mean, I think so. That's I don't know why that's something. Yes.
And I guess in a sense there's order in God, but at the same time there's a certain freedom, and there can be good use of that freedom, but there can also be destructive use of that freedom, I guess. Martha, your thoughts on what stood out to you today?
Yeah, I'm with Gabriella. And through the readings and things, as I was reading those readings, I just thought, oh, I struggled with math so much in high school, and I wish I didn't understand the relevance for me. I just fought it all the way, and I just wish that someone had explained to me that God made this, that you're thinking the thoughts of God when you're doing. I think I would have wanted to do it then. So yeah, I thought that was really cool.
Yeah, that's so good. Belinda.
Just following on from Gabriella's, meaning the maths shows order, it also goes to show that it doesn't matter how you get to that order. You can all go down a different track, but how we all come up with we all got the right answer, but we got there on a different road.
And I guess you face that with your children too, don't you? Is that everyone will want to tackle things in a different way. And I guess what we want them to do is to value one another and doing it differently. But at the same time, we want them to get to that sense of order, because we want them to see reasonable reasons for order. So if we ask them to tidy the room, we want them to think about it. Will it be easier to find something the next time? Or we want them to come up with an aha moment when they discover that. But at the same time, there's a natural tendency, etc., to be wanting to do a million things plus. So so we get to the sense of order in different ways, but we're wanting responsibility that does not kill life. So we want people to be creative in the life. Alex, what stood out?
I think it was good to understand that, math can be a set of propositions, and that these propositions often lead to the dehumanization of students.
Yeah, tell us a bit more about how does it lead to dehumanization, and how do we overcome it?
Yeah, I just think that when we're all being taught one way of doing things, it's sort of like robots or clones, in that it really limits our creativity.
Yeah. I like that.
As unique humans.
Yeah. And so instead of saying you must do it this way, we say, show me some different ways you might do it. And we say, yeah, that would work that way, but this way could be more reliable, etc. Certainly we value your way, but consider this other way as well. Yeah. Abby, your thoughts?
I really liked, I actually wrote this down. It was something that you had on your notes, but it said maths increases our ability to investigate claims of truths that are based on the world around us. And I like how throughout this session, we kept mentioning that it's a way to explain the order that God has established. And it's a way to, I guess, explain creation, if that makes any sense. But yeah, I love that, because like Martha, I absolutely hated math, like I mentioned before, only because I wasn't very good at it. But now that I can see its relevance to God, it's very intriguing. So,
and I was not good at music, but I love to play piano now, because I'm outside a classroom. I was not so good at sport, but I love to play sport now. And so there have to be ways that we can encourage everyone to enjoy those activities that we teach. Shelley-Ann, your thoughts?
Shelley-Ann's she's still commuting on the way home. So
sounds good. And Karen, your thoughts? Thanks for that.
The unmute button would help. I really love that. It shows that the unseen, the things that we can't physically see or touch or feel, can still be studied. And so if math exists without tangibility, yet still shows proof of its existence, and people still believe in it and trust in it and are willing to stake their lives with it, why not God?
Yeah. In that, again, that's the unseen, but there's evidence all around it. And After the break, we'll have a look at maths as evidence of the God of who gives us maths. So let's take our break now, and we'll come back in 10 minutes time at about 10 past. Thank you.